A new paper connects upper stratospheric ozone changes to the solar cycle. Anthony Watts writes this on What's Up With That? Changes in the output of the sun are thought to influence surface weather and climate through a set of processes initiated by the enhancement of upper stratosphere. That's in the 32 to 48 kilometer elevation ozone. In order to understand and assess the solar impact on the climate system, it's important that models reproduce and observe the observed solar signal. However, the recommended data set for comparison with climate models remains disputed. And he says we use newly improved observed ozone composites to determine whether there is disagreement between composites and which is most likely to be correct. We find that artifact-corrected composites represent the response better than those based on SBUV data alone. Further, we identify a U-shaped spatial structure with lobes emanating from the tropics to high altitudes at mid-latitudes. An idealized chemistry climate model experiment and simulations consider historical meteorological conditions both support this conclusion. The results are of benefit to satellite instrument scientists and to those engaged in atmospheric and climate research using both observations and climate models. The results will be important for assessing the polar signal in currently active and future assessments of chemistry climate models. We recommend the basic V2 ozone composite to best represent historical upper stratospheric variability. And the abstract says, the solar cycle, SC, stratospheric ozone response is thought to influence surface weather and climate. To understand the chain of processes and ensure climate models adequately represent them, it's important to detect and quantify an accurate SZ zone, that's solar cycle, SC zone response from observations. Chemistry climate models, CCMs, an observation displays a range of upper stratosphere 1 to 10 HPA zonally aggregated average spatial responses. This and the recommended dataset for comparison remains disputed. Recent data merging advancements led to more robust observational data, and using these data, we show that the observed solar cycle signal exhibits an upper stratosphere U-shaped spatial structure with lobes emanating from the tropics to high altitudes at mid-latitudes. We confirm this using two independent CCMs, that's chemistry climate models, in specified dynamics mode and an idealized time slice experiment. We recommend the basic V2 ozone composite to best represent historical upper stratospheric solar variability, and that those based on SBUV alone should not be used, he says. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.